Okay, here's the third part of the video capture on perfect competition. And in this part, I want us to be able to think in the long run. Just a reminder, a couple things about the short run and the long run we've established so far. In the short run, a firm might make economic profit or take a loss. In the long run, we're going to prove that they will break economically even. So total revenue box and total cost box will be the same size. We'll show how in just a second. In the short run, a firm has fixed costs because it's locked into the industry it's a member of. In the long run, it can retreat from that. You can think of the long run as being maybe when their mortgage or their lease is up on their building, or when they've paid off their long-term loan on machinery that they might have got to buy the pizza oven at my pizzeria, for example. Okay, so we situate ourselves in a condition where a firm is making positive economic profit, and we've seen this picture before, and we think about what will happen with the addition of time. And I suppose that this is a situation where I haven't yet shown a shift of a curve, but we'll go ahead and grab that supply curve. What we're going to think about here is that this economic profit box right here is acting like a magnet, and it's drawing more firms to that industry. Whatever this product is, you remember the third assumption of perfect competition was that it's easy for firms to enter in the long run. So there's not a lot of startup costs, and it's easy to grab your tiny little share of the market and produce the same exact good as everybody else. And this economic profit tells you that people in this industry are earning more accounting profit than they would in some other place, which we defined as normal profit. So this is profit over and above what you could earn doing something else. And it will act like a magnet to lure more firms to the industry. So we'll move that profit box out of the way because it kind of gets in the way of showing what we need to show. But once again, just to be sure, it comes from over there, and this firm is operating a little above capacity. It's sort of overusing its factory, and therefore ATC is a little higher than minimum ATC. They weren't productively efficient. So what happens over time? As firms enter the industry, you remember your good principles about timer and tigers, and this is the S of tigers. And so what that tells us is that there will be new firms in the industry. So we'll just have to clone the supply curve, and we're going to move it over somewhere. And we know that it's going to shift right as firms enter. But instead of drawing it in, don't draw it in yet. Just think about where it's going to go for a minute. It's going to move over to the right. What will really happen, though, is this guy, Mr. Dark, is going to drop as a result of that rightward shift of supply. So if we clone that, we can think about Mr. Darp would drop, and if supply shifted to here, Mr. Darp would be there, right? We'd still have a little bit of a profit box. In this case, the firm would produce a slightly lower quantity. They would produce a quantity right about here. You can see, because that's where the new MC equals MR. And they would still have a little bit of a profit box. Their profit box would come across like that, and it would come up to this spot right here. Okay, so there would still be new firms wanting to enter the industry. So we don't really want to draw that in yet either. What we really want to do, strategically speaking, is think about where Mr. Darp's going to go, and then orient our market graph around that. We know Mr. Darp will drop until there's no more economic profit. And that's when firms are doing just as well in this industry as they would be able to do in some other industry. And if that's the case, then we need to be down here at this P. Well, we don't have enough line for it, my goodness. We'll have to do a dotted line here to get ourselves in the game. It would have to be this price right here. Oops, it's in blue. Anyway, you can see that's about where we would need supply to shift to. And of course, we would use our same good graphing principles, and we're going to give ourselves an arrow here to show. Whoa. We're going to give ourselves an arrow here. To show supply having shifted that way. And we'd have a new industry quantity. And the industry quantity would be over here. And we would call that Q2. We can label that for here, Q2. Notice that the industry quantity increased, right, as a result of this process. And we can think over here what happens to the firm. Well, the firm's breaking even. the firm now is thinking about, where on earth should I produce? I should produce where the new Mr. Darp, over here. And this will be my Q2. Note that the firm quantity decreased as Mr. Darp went down to Mr. Darp 2. That is a process that you need to be able to draw and explain. And the reduction in quantity means that now the firm back in long-run equilibrium is experiencing minimum ATC. They're operating right there at the top of that blue dotted line, and they are productively efficient in their long-run equilibrium. That's the adjustment into long-run equilibrium. One more time, you should have this chain of events in your mind. The entry of firms causes industry supply to move to the right, which causes price to fall, which causes Mr. Darp to go down, and the firm responds to that by producing a smaller quantity. Don't get lost in that paradox. There's more firms, each of which is producing a couple fewer units. That's the analysis from short-run economic profit into long-run equilibrium. We can repeat that process real quick here with a short-run loss. And so we see the situation here where we've got the short-run loss. I've highlighted the part of marginal cost that's supply and tried to make that bold. And what's going to happen here is that firms will exit the industry, and as they do, supply will shift up and to the left. And we'll need to figure out exactly where. And the strategic way to do that graph is to move Mr. Darp up right there to where it's tangent with the bottom of ATC. It turns out our supply estimate right there was pretty spot on. We can go ahead and put in an arrow here to show that supply shifted. Put in an arrow here to show that supply shifted to the left. And we know that the industry quantity would have decreased to over here. And as that industry quantity decreased to Q2, we know now that actually the firm, and this is pretty tricky here, I better use a dotted line. The firm now is going to produce this quantity right here. We can call that Q2. Oh, that looks awesome. And the firm increases its quantity even as the industry quantity decreases. So there's the adjustment from short-run loss into long-run equilibrium. And the chain of events you want to keep in your mind again is that there's an exit of firms, which causes market supply to shift up and left, and that causes price to increase, which causes Mr. Darp to rise, and that means that the firm is going to produce a few more units. Note that they're now productively efficient because they're operating right over here where minimum ATC crosses marginal cost, and so they increase their quantity by a little bit, and there's fewer firms, and so the total industry quantity decreases. So the quantities move in opposite directions because market supply changed, and it was the number of firms changing that caused that. Okay, the last part of our video analysis here is thinking about three different types of perfectly competitive industries. And it's pretty clear to me that you should be solid with the entry and exit of firms idea before proceeding to watch this part. So if you need to go back and think about it a little bit more, you certainly can. I'm going to zoom in a bit. And we're going to think about three different assumptions that might be at play for a perfectly competitive industry as we move from one long-run equilibrium into another. And so the first assumption is the simplest, and that's of a constant cost industry. Most of the time that you see a reference to a type of cost industry here like this, it will be a constant cost industry, and that's the simplest assumption. So the assumption is that the entry of new firms does not change the cost curves of existing firms. So here's me and my pizzeria, and we're operating at minimum ATC and long-run equilibrium. We have no economic profit. I'm earning exactly as much as I could do during doing something else because I'm earning exactly normal profit, but zero economic profit. So let's imagine a successive increase in demands for pizza. So there's an increase in demand, and for a little while, the market's operating up here, and the price is high, and Mr. Darp has gone up, and I increase my production quantity to a quantity right over there. And we know that's not a sustainable situation. I have economic profit, so other people open pizzerias. And as they open pizzerias, the supply curve here shifts to the right. And how far does it shift? Well, it shifts until we're breaking even back in long-run equilibrium. And under this assumption, as those firms entered, my ATC stayed exactly the same. So we go back to the same quantity. And now we're in long-run equilibrium again. And what I'm going to do is drop a red dot every time we're in long-run equilibrium. We'll see what happens to form the long-run industry or market supply curve. So there's a second one. And now let's think about if there's another increase in demand. Well, then we'll have this profit situation. I'll produce a few more units because the price will be higher, and there'll be economic profit, and firms will want to enter, and they'll enter until the price comes right back down to being tangent with the bottom of ATC. My quantity goes back to normal, and we have a new long-run equilibrium point. And these should line up. The idea being that all of our long-run equilibrium points are all at the same price. And so no matter what the market demand is, supply will adjust to keep the price right there. In the long run, a market supply curve will be a horizontal line and really you rarely have to draw this, but the main reason that you're asked to think about this is if you have a long question of free response and it starts you off with a firm in long-run equilibrium, there's an increase in demand, they make a profit, then they ask you what happens as we move into long run, and you're supposed to talk about firms entering like the earlier part of this video did, and then they ask you to compare the resulting price after the firms enter to the price before. In this case, you'd be able to say with confidence those prices were exactly the same. So all long-run equilibrium points have the same price. So that's one assumption. Now we could change that assumption if we imagine instead of pizza. See, why would that assumption maybe be true with pizza? One reason it's probably true is that as you people decide to quit high school and open pizzerias because you can make economic profit and you're thinking in the short run because you're teenagers, there's no change to the price of labor and to the price of cheese and to the price of tomato sauce, because a few more pizzerias in Iowa City wouldn't really change the price of those commodities on the bigger, broader market. So that's why my ATC curve stayed exactly the same. And you could rent 3 or 4 places to become pizzerias without really driving up the cost of my rent. Now let's change the product and change the assumption a little bit. Here, we're dealing with what's called an increasing cost industry. So our assumption is that the entry of new firms pushes other existing firms' cost curves upward. Now let's imagine instead of running pizzerias that we're making gold rings. Okay, now what are the inputs necessary to make gold rings? Gold and jewelers and goldsmiths. And those are both kind of rare commodities here in eastern Iowa, I would guess. And so as we demand more gold and more goldsmithery, we push up the price of gold and we push up the price of goldsmiths. And as a result, the ATC curve that I experience may change when there's more firms. So let's see how that would work out. Let's imagine again that we have an industry demand curve increase. We were in long-run equilibrium, and the demand curve increased. So now, Mr. Darp is up here, and I'm producing this many, and the industry quantity is here, but we're not in long-run equilibrium. And so more people decide to start making gold rings, and they do. But as they do, they push up the price of gold. Oh, they push up the price of gold for me. And so my resources get more and more and more expensive. Now, maybe my marginal cost doesn't change, but here, maybe let's just bump my ATC up a little bit and see what happens. So firms enter, but they only enter until right here. And now everybody's breaking even, but we're breaking even all at a slightly higher price than we used to be. So we'll drop another long run equilibrium dot there. Let's just rinse and repeat to make sure we're clear about where we are. We're back in long run equilibrium, but the price is just a little bit higher than it was before because there's more firms making gold rings and they've pushed up the cost of producing a gold ring because they pushed up the price of the inputs that's necessary to make it, the gold and the goldsmith's labor. So now let's say gold rings get more popular again for whatever reason. And then the industry quantity is here, but we're all making a profit for a while, and more people decide they're going to go into selling gold rings, and they do, and we end up here. But as they went into making gold rings, they pushed up my ATC just a little bit more, and so here I was. And now let's think about us being right there, and we're in long run equilibrium. Some firms entered, but not enough to bring the price down to where it was before. Now what we have is a low sloping but upward sloping long run industry supply curve, because we can see that all these points of what would be the quantity all the firms would supply of gold rings at any given price be, and it slopes up. So we can come down here and generalize and say what we have is a long run industry supply curve, SLR. Sorry, it's messy. And there you go. Probably that's a more real world example than the constant cost industry, but the constant cost industry is the most commonly tested of these. You know, the third of these is totally the weird one and totally the challenging one to wrap your brain around if you think about the consequences, which makes it kind of fun, I guess. So this is what's known as a decreasing cost industry, and the entry of new firms into the market pushes existing firms' cost curves downward. So an example that might work for you is if you think about the market for laptops. And firms make laptop computers. There's now lots of firms that can produce laptop computers relatively cheaply. They used to cost a ton. And so let's sort of think about maybe why that might be. Let's imagine that it was perfectly competitive. Probably no industry really is, but we'll go ahead and ascribe those principles to it for purposes of analysis. So here we were in long run equilibrium at some point long ago when a laptop computer cost lots more than it does now, is my estimation. So let's say that it got popular to have computers because as college students you want to do your papers on computers and so forth. So now it becomes profitable to do that. Mr. DARP goes up and the firm produces a little higher quantity. And so firms say, hey, we need to make those. We need to be able to make those too. And so they decide to enter the market and make a bunch of them. Now, as they do, and here's the bizarre thing, my average total cost curve may drop if I am a computer producer. Let's think about some reasons why that would be true in the computer industry. What does it take to make a laptop computer? I've not made one myself, but I think there's circuitry and there's some electricity and things going on inside of there, and there may be a board of mothers or motherboard, and there's some microchips. And I think that all those things are things where it's really expensive to make the first microchip, but to make the 1,000th microchip is probably even cheaper. So as the microchip producers, the people, the little people at Intel, as they make the little chips, as they make more chips, it gets cheaper to make each chip. So as the industry quantity of computers grows, more and more chips are made, and then each chip is cheaper, and each chip is a big part of the cost of the computer. So the computer gets cheaper. So my ATC went down as all these firms entered. And so as a result, we come into a new long run equilibrium right there, maybe. And I'm producing this many. And here's our new red dot. And then let's say that people decide that they need to have a work computer and a laptop computer for home, and a lot of people are telecommuting and their business gives them a computer, and so there's just more demand for computers, and more firms decide to enter that market, and they do. And as they do, the cost of the Intel processors that go inside of the motherboards and things gets cheaper. And so there goes down Mr. DARP as the firms enter. But as this happens, my ATC goes down a little bit too. And we might come to rest somewhere like here. I'm producing that many, and we're in long run equilibrium. And every firm is producing Q star in the green over here. The industry quantity is all the way over here, but price has now dropped from P1 to P2 to P3, and we could see that price process continuing to drop. This might explain why the district can give you a Chromebook, which is pretty cool, actually. So we would say in this case that the supply curve in the long run for the industry is actually downsloping. And please don't get too tied to a downsloping supply curve, because in general supply curves slope up and demand curves slope down, and you don't want to be doing a downward sloping supply curve very often. So just a little familiarity there with some of the key terms that were on the vocab sheet. At this point, you should have gained the types of industries knowledge and entry into market, exit from market. And we've thought all along about long-run characteristics and productive efficiency. So hopefully this continues to solidify your knowledge of just about all the terms that are on the back of the unit schedule. Thank you.